So hello and welcome back to this video series of the Barcode Property Finder. In the last video, we just go through the evaluation of the 1D codes, and in this video, I will show you how you can evaluate the 2D codes area of the Fogra Barcode Testform. We still use the lexicon for this evaluation, so just let's start. Just let's go and we see what results we get there.
Diese Konferenz wird nun aufgezeichnet.
So we now in the 2D codes area. So we have to first measure as a we first have to figure out which. So now I can show you it in the notes of on the evaluation. We want to figure out if a negative contrast suits you better for your printing combination or a positive contrast. So what does it mean? So black ink on a white surface or the white ink on black surface. So the code segments are printed or not printed. So therefore we have to look it up here. We have to measure first this area and this area. If you want to know which codes that are, you can find it here on the patch arrangement of the Fogra Barcode Testform. So let's start and we just go ahead.
Diese Konferenz wird nun aufgezeichnet.
So now we want to figure out which contrast suits us the best for this printing combination. So we just start, we just measure C1. Okay, there went something wrong. So we got 4.0 for C1. Then we just go through the measurement process. So for 1D codes, we
Diese Konferenz wird nun aufgezeichnet.
So let's go on for the 2D evaluation of the Fogra Barcode Testform. So we want to figure out which contrast suits us the best for this printing combination. So we just measured it here. Then we got a 4.0. Which contrast suits us the best and depending on the BVR of bar with reduction of the 2D symbols. So 4.0. Also 4.0. So then we just measure this through. So there we get only a 1. Then we go on with the negative contrast and figure out which BVR is the best here. So it's 4.0 there. Already dropping here. So for the 2D evaluation, we only need one measurement. So we make one picture of the barcode, and then there will be made a gray balanced histogram, and the measurement will be evaluated after this histogram. So we don't need 10 measurements like in the 1D code evaluation. We only need 1. False, so it's not okay. That's also not okay. So that's also that's for step 1 and 2. So that's it is so far for step 1 and step 2. So we go on and put these measurements into the barcode property finder and see what will be the next steps.
Diese Konferenz wird nun aufgezeichnet.
So we just made the measurements, so we put them in. So 4 is right, 4 is also right here. Then we already also have therefore everything is 4 instead of the last barcode that only gets a 1 here. Then we go on with the negative contrast. There we got a 3. They're also 3, 4. And then it's already 0, 0, 0. So then we got our measurements for step 1 and step 2. The best code for positive contrast is C1, and also it's the first barcode for the negative contrast, so we don't have to put on a bar width reduction on these codes, and in this case, and we just can print them out. So we don't have to make any further corrections in the pre-press workflow for these barcodes. So the next step, we want to figure out which color coding suits us the best in this printing combination. So we just went back to the measurement software and measure these codes. If you want to know which codes there are, you can look it up here, but it's actually the first row here. So this area there. So then we measured these. So let's go on. Oh, no, we don't measure this. So we don't have to measure the first barcode. We only have to measure the following 4 codes. So there we get a 3. There we got a 4. Also a 4. So after we measure that, we put it into our barcode property finder. So it's already right here. So over the time of the research project, it already figured out that the color encoding is not that important for 2D codes. It is like for 1D codes. So there's much more impact on 1D codes than on 2D codes, but still, it's still good to evaluate these areas to make sure that your printing combination is not affected on the color coding. But actually, the most time it hasn't got this big effect on the quality of the barcodes and for the 2D codes area. So we already got here our overview, so you can see the evaluation statistically. And then we go on to measure which model size suits us the best. So what is the smallest possible 2D code with the best rating we can print? We'll figure this out right now. So what we want to measure here, we go on the nodes are again and see, okay, we have to measure this area here, and let's do this. So, right, good. Then let's go on here. Oh, no, thank you. I don't need this. Then we want to try to measure the first one. Let's see what's happened. He couldn't recognize it, so we give this barcode as 0. It's not readable actually, so we have to smaller the frame here a little bit. It's also not readable. Then just go on. So there's the first readable one. It gets a crate of a symbol crate from 1.0. Then we have, maybe it's working out. Just let's see. I think it should be enough. Yeah. So 3.0. We have to make it bigger here so we can measure the next code. So you can already stop the measurements here because we already got the first code of 4.0. So you don't have to get further. So you only have to measure until the first perfect grade. So it's in this case, it's 4.0. Or it's always 4.0. So you just have to look it up, then measure it until the first perfect grade is achieved. So 0 is here for the first, for the second also. Then the third one is also a 0, then a 1. Then we get a 3, and then it's already a 4. So what does it say? In this case, it's possible to print a 2D code with a module size of 0.35 millimeter. What is a model? A model of a 2D code is one part, so one square of the barcode. So it is possible to print a model size of 0.435 without a loss of quality. But the readability of the most scanners has been already improved that much. So I think it should be possible in this case also to print a 2D code with a model size of 0.3 without any lack of quality. So you can print that with a 0.3. So we can look it up in our free already, what our results look like. So for 1D codes, we already have that in the last video. We have the best code in A2 for this combination. Then the best for the ladder codes. For the picket fence codes, it's B5. So optimal bar width reduction with 15%, and for the picket fence is 0%. Best color coding is 100%. So BU score, barcode uniformity score, it is called. We will see this in the next video, and I will make an explanation about the BU score. So then let's go here. You got also your graphics. And then there's the evaluation of the 2D codes and the overview. So I think we are done with the 2D codes evaluation. So I will see you in the next video, and there we will discuss the barcode uniformity score. And thank you for your attention, and we see you. I hope I will see you in the next video.